minima at 3 and value is equal to 6. Is it fine? We can see that critically also because we know those methods which we have learned earlier. So your function is x square minus 6x plus 15. The candidate for minima will be wherever derivative is coming equal to 0. So you take its derivative. So it becomes 2x minus 6 equated to 0. 2x minus 6 is 0. 2x is equal to 6. X is equal to 3. And then you take double derivative of it. The double derivative is turning out to be 2, which is positive. That means this is a minima, local minima by those derivation tests. And at f is equal to 3, if you calculate, this is 3, 9 minus 6 into 3 is 18 plus 15, which is turning out to be equal to 6. That's what we are getting from this golden section method as well. Is it okay? Is it fine, right? I will be posting this Excel sheet as well in your Google Classroom along with this note. So if you have any doubt, maybe you can ask me later on also. But I think it's fine, mostly fine. You are more comfortable with Excel than me.
Yes, ma'am. Okay.
Yes.
Okay, so if these things are fine, let's move to the next line search method, which is exactly similar to the golden section method. Actually, golden section method is a kind of generalization of this method. The golden section method is easier to implement than Fibonacci search method. Now, the next method, next line search method we are going to understand is Fibonacci search method. Fibonacci search method is more difficult to apply than golden section search method. Just more difficult, I'm saying that, just very small differences there that you see in a minute. But it is, as you can expect, that it will converge faster. So that means in less number of iterations you will get desired result in case of Fibonacci search method. So it's there are pros and cons. The pros that both I have explained to you. It is little bit complicated to apply than golden section search method, but it will give you result in less number of iterations for for some function rather than golden section method. So in the beginning of Fibonacci search method, you need 3 things. So we are again learning method for minimizing. So we have to minimize a function. This is objective function. And then here you are given allowable length of uncertainty, means how much error we are allowing, where to stop. And then we have initial interval of search. Okay. So in golden section search method, we simply started finding, we simply started first iteration. But in case of Fibonacci search method, we first need to decide how many iterations we will do. In first step is to decide number of iterations. So how we decide number of iterations? So for that, I need to tell you that what is Fibonacci sequence. I hope many of you already know this. So in Fibonacci sequence, there are many ways. There is sometimes not matching in the beginning. So I'm assuming F1 is 1, F2 is 1. After that, we are supposing F1, Fn is sum of previous 2 terms. So this means F3 is F1 plus F2, which is 2, sorry. And F4 is F3 plus F2, which is 1 plus 2, which is 3. Similarly, F5 is F3 plus F4, which is 3 plus 2 is 5. So these numbers are called Fibonacci numbers, and this sequence is called Fibonacci sequence. So now you are getting 8, F7 is 5 plus 8 is 13. So this sequence we are getting 1, 1, 2, 3, 5, 8, 15, 13, 13. Then after that you will get 21 and so on. This sequence is called Fibonacci sequence. Okay. And we are using Fibonacci sequence to find Fibonacci search method. Now, what is the relation between Fibonacci search method and golden section method? If you take, I don't know if you understand limits or not. If you take this limit, that you are taking ratio of two consecutive Fibonacci numbers and n is tending to infinity. So then this number turns out to be equal to 0.618, which we were deciding. So if you see, so earlier it is f1 by f2. In my case, it is same as 1. Then this is f2 by f3. This is 1 by 2. Then you are taking f3 by f4, which is 2 by 3. Then we are taking f4 by f5. This is equal to 3 by 5,
5.
right? f5 by f6. So this is now
5 by
5.
8.
5 by 8.
So maybe my numbers are too small. So this is 8 by
8
13.
by 13.
So 8 by 13 is approximately how much in decimals, in digit? Yeah,
0.615.
0.615. And here what we are getting?
0.619.
0.61. Okay, so so it's, you can see that as we'll take n larger than larger, this number will start approaching to 0.618. Here already it is quite close to 0.618. So this is how the golden section method is kind of simplification of, in terms of application, simplification of Fibonacci search method. So here you can also see this number earlier was that golden ratio number. So that D, the D, which is 0.618, this number, exactly everything is exactly same. Maybe I have switched x1 and y1, but that does not make much difference. So Subhash, you have any question?
Yes, ma'am. The last thing which you are talking about, the relationship between Fibonacci and the golden search, there is a equation you wrote, right? The Fn divided by Fn minus 1, I think, right? Let's go back to the previous.
Okay.
Fn minus 1, limit of Fn minus 1. So in this equation, the terms like Fn minus 1 divided by Fn, how does these terms corresponds to Fibonacci and golden?
No, so they are coming from here only. That's what I'm telling. So these are Fibonacci numbers.
Right.
So Fn minus, these are two consecutive Fibonacci numbers. So I'm taking ratio of two consecutive Fibonacci number. The thing what I'm doing here I'm taking n is equal to 2. From here, if you compare, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8. So these are ratio of two consecutive Fibonacci numbers. And this, I'm telling you that this ratio will start approaching to 0.168. We have done just till 6 7, so it is coming very close to 0.618. So if you remember this, we were using in golden section method.
Yeah,
So
right.
in golden section method, when you are finding x1, that was a plus d, and how you were deciding d was g times b minus a. Okay, this is what we were doing in golden section method, right?
Right.
So now if you see, the same thing is done in Fibonacci method, but instead of this d is replaced with ratio of Fibonacci numbers. Okay. So Fibonacci golden section method is a simplification in terms of application of method of Fibonacci method. Okay. So as I told you that in Fibonacci method, the very striking difference in terms of application is that in case of Fibonacci search method, you have to decide number of iterations right in the beginning. So how we'll decide number of iterations? You will do n-1 iterations, and you choose fn such that fn is greater than length of uh, length of interval divided by allowable length of certainty. Okay, I will show you that how this works in example because it is easier to understand there. So apart from this difference, everything else is exactly same, and there is a difference in deciding x1 and x2, x1 and y1 also. Apart from that, it is same, exactly same as golden section method. You will choose x1 after finding this f1. You will by this formula you will find x1, by this formula you will find y1, then you will compute function values, then you will compare whether function value at x1 is higher or whether function value at y1 is higher. Accordingly, we will reject some intervals. So if we are in this situation where function value at x1 is higher, so that means minima is closer to y1. So in this case, we will reject this portion. Okay, and if we are here where function value at y1 is higher, that means minima is closer to x1. So in this case, we will reject this portion. Okay, then you will choose new interval of length. After that, you will apply the modified formulas. So this will be replaced. You will again find x2 and y2. And at kth iteration, xk will be given by this formula, yk will be given by this formula. And this I'll discuss later. So here I'm telling you that x2 will be same as y1. So similarly, in golden section, like golden section method, after second iteration onwards, you need only one evaluation of function. The one of the number will be same as the previous number. And just because there was a question in previous, when I was doing the question, uh, when I was doing the question of golden section method, so there was a question regarding that why these two numbers are coming same after second iteration onwards. So let me address this. So what I'm going to address, so I'm actually going to show you that if you are in this scenario, and means you are selecting based on value of phi x1 and phi y1, you are selecting this as new interval of search, then your x2 will turn out to be same as y1. This is a very simple derivation. Let's do that. So we are saying new interval of search as x1b. This is okay. Maybe I open somewhere here. Okay, and then x2 is equal to b2 minus fn minus 2 fn minus 1 b2 minus a2. So this is same as new interval of search a2 b2. Now you put these values. So x2 is b2 is same as b. This is fn minus 2, fn minus 1. b2 is same as b. a2 is same as x1. Okay, is this fine? Are you with me till here? Is it okay? How I am writing? Is this fine?
Yes.
Okay.
So that is being
Yes,
taken
sure.
from the last interval, right? So
Okay. Yeah. Yes. So we are changing as per this interval. Then we are putting the value of x1. So value of x1 is b minus fn minus 1 fn b minus a. Okay. So now Yeah, just bear with me. I'm just doing some adjustment. So what is happening? Let's see. So here, this is nothing. So this is B minus B. Then I have minus Fn minus 1 Fn B minus A. Okay, this will get cancelled and this minus minus will make it plus. So this is B plus Fn minus 2 Fn minus 1 times Fn minus 1 by Fn B minus A. Is it okay? Fine. Now you see.
The equation out at the top, right? X2 equals to B minus Fn minus 2.
Sorry?
Professor, it should be 1 minus Fn minus 1 upon Fn, right?
Minus, minus. Yep.
B minus B will get cancelled. It should be okay. Sorry, my bad. Fn minus 1 can be cancelled, right?
That's what I'm going to do in next step. So, but there is a sign problem.
Yeah.
There's a sign problem, ma'am. That should be a plus at the
In
top.
earlier line, there was a
There is a
problem.
minus,
Minus.
B minus. It should be B minus.
It should be a plus.
Fn minus 1.
Okay, minus minus will
Ma'am,
make it plus. Okay, when I
Yeah,
open
plus.
this,
Yes.
and after that, this will remain minus. And sorry. Okay, so this is minus. Okay, fine. So now everything is fine. So this becomes B minus Fn minus 2 by Fn B minus A. Now we know that this Fn is equal to Fn minus 1 plus Fn minus 2. This is how it is defined. So Fn minus 2 is same as Fn minus 1. Is it okay? It's the definition of Fibonacci sequence. So from here, B minus Fn minus 1 by Fn B minus A. So from here, what we are getting, this is B minus Fn by Fn will turn out to be 1 minus Fn minus 1 by Fn B minus A. Now you just open it and we are getting, this is B minus A minus minus plus now. So here I'm again, okay, minus minus plus. So this is it fine? And this was the value of y1. Is it okay? So this is not that in calculations we are getting these numbers magically, but this is how the algorithm is designed. So here also the similarly, if you start from this y2, you take this interval, you replace value of a2 with y1 and value of b2 with a1, and you do this similar calculations. This number will turn out to be equal to x1 in this case. Okay, so I think so this is here just for your simplification. I have written that it at kth iteration xk will be equal to this. So this number will be fn minus k divided by the next number, and ykth have this value. So let's start this thing I'll explain later. Let's start one question first by hand, then we'll see same question on Excel as well. Okay.
Can you please show that derivation for a minute.
Okay. Yeah, I can show you the derivation in a minute. I hope I've not done any calculation mistake.
Just the end part.
Okay. Here, is it okay?
Yes.
You don't need to do this derivation. I'm doing this derivation just to show you that how this works. Okay.
Okay. Yes, ma'am.
Okay.
Sir, just one question. So, in case of very complex polynomial equations, is Fibonacci series is a better method in calculating the minima or maxima?
So, see,
It's not for polynomial, right?
So the one thing is that the function has to be unimodal. Now I don't know what do you mean by very complicated polynomial. If that complicated polynomial is not giving you unimodal function in certain intervals, then you can't apply either of this method. Both methods are for unimodal functions. Fibonacci method, I don't know whether I explained that in the beginning. So
My intention of asking is that how better is Fibonacci with respect to golden search, since both of them are having, the same, not the same output, but the similar output, similar approach.
Unimodal function with single minima in interval of search. See, I told you that it depends on what is your preference. See, golden section method is easier to implement, and Fibonacci method is little bit complicated to implement because at each step you have to decide. There this D was fixed. We were not changing this D at any iteration. But here in Fibonacci method, this number is changing at every iteration. Okay. So, so it's little bit complicated to apply, but then the benefit of this that it will give you solution in less number of iterations. So if your function is such that evaluation of function is very costly, so in that case we will be like to have solution in less number of iterations. So in that case you will prefer Fibonacci search method. But if suppose your function is very simple and it does not matter to evaluate it at more, you don't mind couple of more iterations, then you can simply apply golden section method because that is easier to implement.
Ma'am, actually, these are the two methods we are using for computing minimum, right? So, what about for maximum? Like, do we have
So
other
for
methods?
maximum, you will be using the same method. You suppose if question is find maxima of 5x, you will find minima of minus 5x. It's not like that you will use some other method. You will be using the same method. I told you in first
Okay, ma'am.
lecture
Yeah.
itself
Yes,
that
yes.
finding minima of some function is same as finding maxima of the negative of function.
Yes. Yeah.
Okay,
Thank you.
so let's start quickly with this question so that we can complete it in today's class itself. So the first thing is that you have given this length, so I need to decide fn. So in first iteration itself you need value of fn because x1 is b1 minus, so I need to find what is this fn. So this fn here I have told you is given by this thing that b1 minus a1 divided by l must be less than fn. Okay, so here let's write couple of values of Fibonacci sequence just for our convenience.
Ma'am, please.
Can you go back to the question? Yeah, same thing.
Okay, so here this is your interval AB. So this is length L. So I compute A minus B or B minus A because I'm taking mod, so it does not make much difference. But let's write correctly. B minus A divided by L. So this is 5 minus of minus 3 divided by 1. So this number is coming out to be 8. So I have to choose Fn in such a way that F8 must be less. So I will be choose it as F7, which is equal to 30. Okay, it should be strictly less. So this is from here we are starting. So we are taking we are computing x1. X1 is.
Ma'am, what you said in the last sentence, we choose Fn in the way where what is less, ma'am? Can you please?
This ratio b minus a by l must be less than Fn, strictly less than Fn.
Fine, ma'am. Please, thanks.
Okay, so x1 is b1 minus f6 by f7. So this is Fn, this will go in denominator. B1 minus A1. So this is your interval B minus A. So here B is 5 minus 8 by 13 into 8. So this is your x1, and y1 is a1 plus f6 by f7, b1 minus a1. So this is minus 3 plus 8 by 13 times 8. So if you do this calculation, this number turns out to be equal to 0.077. This number turns out to be 1.92. Okay, so the next step is you compute phi of x1 and phi of x2. So if we compute phi of x1, that is x square plus 2 x1 square plus 2x1. This is x2 square plus 2x2. For these values, phi of x1 is 0.77 and phi of 1.92 is equal to I have done this calculation beforehand just to save time here. So this is, but please tell me if they are correct. So this is turning out to be 7.54 and this is 0.15. Am I correct? Is this correct?
This is y1 now, ma'am. Phi of instead of phi of x2.
Oh, y1. Sorry.
And the x1 value in the calculation was written as 0.077. Is that 0.77 or 0.077?
0.077. Yeah. Is it correct now? You
Then
can
the
also
value
text me. What are you getting if you compute? I think 0.077 is correct.
Yes, 0.077.
0.077.
Yes.
And after that, this calculation, I'm getting this. This is also correct. I think so. Is it fine? So now we are in this scenario.
It is 7.52.
Sorry?
The 5y1 is 7.52, not 54.
This is coming out to be
Yes,
5.
ma'am.
Okay,
Yeah.
fine.
Yes, ma'am. I'm getting 5
Okay, fine. Okay, so this is minus 3. So we have 5 over here. Then x1 is somewhere very near to 0, but on this side. And y1 is somewhere here around 1. Okay, around 2 actually. Okay, so if you see at value at y2 is around 8, and this value is very close to 0 again, but on upper side. So if you see the minima will be closer to x1, so we will be rejecting this portion. So new interval of search is
y1 to 5.
this is minus 3 to y1, and y1 was 1.9. What it was 1.92. Okay, so this is A2 and B2. Fine. So in next step we are writing x2, and in case of
can you show the graph, Lima? Just to
so x2 is
y2 will be on the
B2
y-axis,
minus.
is it?
Sorry.
Y2 is y1 is going to be on the y-axis, is it? Y-axis.
Have you joined just
y1?
now? Have you joined just now?
No. I am attending since beginning.
Okay, then you are not getting that what y means. See, on this side we are plotting the points. On around y-axis I'm plotting function. This side I'm plotting function. It's not here, y is just a notation, not a point on y-axis.
Okay.
Professor, it should be f of 5 by f of 6, right?
F of 5 by f of 6. So earlier we did
f of 6
by 7. Yeah, you're right. Maybe I'm looking at some wrong iteration. Thank you. Earlier we did 8 by 13. So now we will be doing
8.
This is f5 by f6. And what is f5 by f6?
15.36 minus 0.92.
What is okay? 5 by 8.
8 by 13 or that was
Five by
correct. 5 by 8.
8.
5 by 8.
Point.
Then we are getting, this is plus 3, their difference. So this, please tell me what are you getting. And similarly, we compute y2. Y2 is
72.
y2 will be same as x1. That's what we have computed, right?
Yeah.
In this case, y2 will be same as x1. So we won't even compute that. That is whatever it was. X1 0.0077, and we know that phi of y2 is 0.1597. What this value you are getting? This is equal to
This is the
minus 1.1538. Okay, maybe too many digits, but okay. So if you
1.155.
compute phi of x2, you are getting minus 1.9763. Is it fine? Are these calculations matching with yours?
Ma'am, how
Let,
y2 equals to x1?
let's plot it. So now what interval we have? So we have from minus 3 to 1.923. Then x1 is somewhere, this is y2. Y2 is here and value is very near to 0. But then x2 is negative, x2 is near to 1, so somewhere here, and value at it is also negative, which is around 1, which is here. So function is decreasing again on this side, so we will be rejecting this portion. So the new interval of search is minus 3 to y2. Y2 is 0.077.
Yeah.
Okay. Fine. So this will become third iteration. Let's do one more iteration. Then maybe we'll do it by Excel. Okay, so we are taking, this is A3, B3. This is minus 3, 0.077. Then we have X3 is B3 minus, what should I write? Please tell me. B3 minus
Can you
A3.
please go on mute?
So we had F6, F5 by F6, now F4 by F6.
4 by F5. F5.
F5, yeah.
Excuse me, ma'am.
So what, please mute yourself.
No, ma'am, just a mistake. I noticed that's why.
I think the Prabhakar is not mute actually.
Sorry for that, but I was not making any noise though.
Ma'am, in iteration 2, you took F5 and F6. It should be F6 by F7.
Why?
Ma'am,
So in first iteration, we have taken F6 by F7. In next iteration, we'll take F5 by F6.
Because B2 minus A2 is 4.92, correct? So next Fibonacci number is 5. So it is Fn minus 1. So Fn minus 1 means F4 by F5.
I'm not getting you.
Ma'am,
So we started with F6 by F7. After that, you will go by F5 by F6.
This step only, F5 by F6, I am saying it is how we are deciding F5 by F6. It is like B2 minus A2, correct? So what is B2 minus A2? B2 minus A2 is 1.92 minus of
No. So we are not deciding at every step. You are deciding only in the beginning. After that, we are sticking to that. After that, it is just decreasing by 1. So it at second iteration, this is Fn minus 2, Fn minus 1. Okay, we are not doing, so you mean to say that I do this step, which step? You mean to say I do this step? No, we are doing this step only in the beginning. After that, we are not doing. After that, we are just decreasing by 1.
Okay.
Is it okay? Ishani?
Yeah.
Good question. Okay. So here I have computed x3 will be equal to this, and similarly like the previous one, x2 will be same as y3. So this is phi of x2 will be same as phi of y3, which value was 0.9763. So now if you see, if you plot, so what is happening? So we have over here what we have, -3. Say this is -3, this is 0, then we have very close to 0, 0.077. Then x3 is -1 point around 2, -1.769. Then x2 is same as y3 is same as x2. What was x2? x2 was -0.9. No, that was the value of phi x2. But what was x2 itself? X2 was -1.
1.15.
-1.15. So it is -1.15 near to 1, -1.15. Now value of function is in negative. So here it is 0.9, -0.9. And here it is -0.4. So it is decreasing in this direction. So decreasing in this direction. So we will be rejecting this portion. Okay, and new interval of search is -1.67, -1.15. Okay, after that we are doing another iteration, or shall we switch to Excel?
Yes, please.
Yes, ma'am.
Yeah.
Okay, so okay, we switch to Excel, then we'll do over there. But there is a point to make.
Ma'am, I mean,
Okay, I'll do that later.
the new
So let's
interval,
do it by Excel. Then
here,
we'll see that.
new
Sorry.
interval is, -1.7692 to 0.077, right?
Sorry. Yeah, thanks. I was thinking that why interval size is smaller than expected.
Ma'am, one more
Thank you.
question. When we starting this example, you said like we have to decide the number of iteration in the first point itself.
Yeah.
But it's keep going. I'm just want to understand.
No, it's not keep going. We are not doing enough of them. So if you see, I'll tell you that how they will stop. So if you see, I told you in the beginning that if this number is turning out to be 7, that means you have to do 6 iterations in total.
Oh, okay, got it.
Okay,
Yeah.
so we have done 1, 2, 3. 3 iterations we have done. So to reach at some conclusion, we have to do at least 3 more. Then this interval length will come less than size 1. So still that size is 1.7 approximately. So it's more than allowable length, but I don't want to do this calculation by hand, or maybe if we get time, then we can actually do, but let's implement it on Excel because it's a little bit twisted than the golden section. Golden section was easier to implement than the Fibonacci method. So let's implement Fibonacci method also. I have tried it earlier, but let me try it again in front of you. So okay, I did it twice for same function. So what we need, first we need to generate Fibonacci sequence, and let me see that what parameters I'm taking. So function we are taking same, allowable length we are taking very small. Okay, the x square plus 2x is our objective function. Length we are taking so that we do too many iterations. And then starting interval is I'm taking same -3 to 5. And we are writing also iteration number. So here you see our interval is -3 to 5. That is 8 divided by, this is allowable length we are saying. How to do that? This is around 4,000. Oh, that is too big. Maybe we do 0.02.
कैसा है 400 होगा ना फिर
400 हो गया. Okay, 400 is okay. So we need to now this is 400. Is it correct or not? Okay. So now what we are doing, we are generating Fibonacci sequence. So here in 2 columns I'm doing it. I have seen there is a method to do it in 1 column also, but let's not go into that. This is equal to Is it okay? Or wrong? No, we are not getting. No, this is not wrong. This is wrong. So here we are doing B5, 6, B7, then so we are not getting 2 over here. So delete. So this is equal to this one. Then here what we are doing, A5 plus, so this plus this. So next time it will add, no, this is wrong.
Ma'am, A6 will be A5 plus B5. A6.
No, it's also wrong. So this is 1, this is 1, then we are adding them. After that, I'm saying this is same as just this entry.
You can do this. Put A7 as 1, A5 is 1, A6 is 1. Then you can put A7 is equal to some of the formula.
Okay, let me see what I'm doing over here. So I'm taking this as 1, this as 1, this as 1 as well. Okay, copying from here. Okay. So what I'm doing, so this is 1, this is 1, then we are doing equal to from here. Then after that, we are adding this number plus this number. And hopefully this will work. Okay, I think this will work now. Let's see. Yeah, no, it's still not working.
You need to add A5 and B5.
Ma'am, A7 is equal to A6 plus A5.
Yeah.
I need to add these two. I'm not getting.
Yes, A5 and B5.
This is same as this, then this is same as from here and here. I'm adding. Okay.
You need to do one more row and then scroll, I think.
This is B5. Then
I think this is A5 and A6.
A5 plus B5.
A5 and A6, yeah. So this plus this one. Enter. Now I think it will work. Yeah, 1, 1, 2, 3, 5, 8. Okay, fine. So we are going till 6, 10. So this is what we require because this is coming out to be 400. So if this, whatever number is this, 6, 10 is what we are starting with. But I have to write because it will choose that way. So I think I have to write from this side. I don't know how to copy that. So maybe I just type it. 1, 2, 3, 3, 1, 4, 4, then 8, 9, 55. Okay, so this is, I think, is fine to work with. So the first, let's write the iteration number because there is an important message over there. Okay, so the one, 2, Then we are doing the second iteration. We'll do that later. So here A, then B, then we have the ratio. Okay. Or we just write ratio equal to this divided by this thing. Okay. So this is ratio, let me call it D. Then we are doing D times B minus A. Then we are doing X, Y, and then we are doing F of X and F of Y. I hope this will work. This is not the way I was doing. So this is minus 3, this is 5. Then D is for here, coming from here. This will be this divided by this. Okay, then this is equal to D times B minus A. Okay, what is that? Why? Why? What? Why?
B minus minus. We need to give in bracket, I think.
I'm giving bracket. No?
I5 star.
Star, star,
A is
star.
also minus.
Star you have to give here.
We don't write star. So I'm skipping here too. Sorry. Okay, so then this is X. So X is basically what we are writing for X. Let me write down. Let me see. So what was the X? X is B minus D. B minus this ratio. B minus this number. Okay. And Y for us is A plus this number. Okay. So these are coming. Are they same as what we did? No, here this value has changed. So they are not same. So this is now X square. Okay. This square plus 2 times X, and this is Y square plus 2 times Y. Okay, so I hope after this it will work. So here this A value again, if condition is there. So if fx is greater than fy, then what we do? If fx is greater than fy, then what happens? It changes or it remains same? Tell me. If you are taking, anybody is taking notes. If fx is greater than fy, it will change. A will change to x1.
X.
X, yeah. And otherwise it will remain same. Okay. And here, if fx is greater than fy, then b will remain b. Otherwise, it will change to y. B will remain same. Otherwise, it will change to y. Okay, fine. Then D is coming. I hope it will take correctly. No,
I think there is.
So here we put this D6 by D5. So it will take automatically or not. Here it was taking. Let me see how I did.
Drag it.
You can drag and check.
Yeah, I'm dragging and checking, then it's not taking. It's changing, right? It's changing because numbers are very big. It will take formula. Yeah, it's taking formula.
Copy from
Yeah.
that row 5.
Yeah.
Everything
Yeah,
and
it's
paste.
correct. It's correct. It's taking. Yeah, good. Fine. This is happening. Now, please mute yourself. Please mute yourself.
Copy from that row 5. Everything and paste.
Please mute yourself. 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 Okay. So how many iterations we are doing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. 14, 15 iterations we are doing. Yeah, thank you. Okay, so let's do 4 more, then I'll tell you that what is happening. Huh. So now actually it's not coming here. Why so? So here you see this number turns out to be here it is happening. It's 13 iterations we are doing. Delete this one too. So here you see at this position what is happening. We still have to do one iteration. We need to do 14th iterations, right? Because this is F15. So we need to do 14th iteration. But see what is happening here. The value of X is same as value of Y. So Fx is also same as Fy. So but in algorithm, we were going to next step if one is greater than other. So it was randomly taking something. So after this iteration, what we need to do, that we need to decide. And this is not happening here by chance. It is coming due to theory of Fibonacci search method. I'll show you this part. So is this fine? Is the problem clear to all of you? That what? So here also, because we need to do 6 iterations. So after 5th iteration, this situation will come. Okay. So here we need to do total 14 iterations. So after 13 iterations, we are landing in this situation where X is same as Y, and that is coming from theory. So so see, I have told you the value at kth iteration. So let me write these values again. Then I'll tell you that what is happening at n-1 iteration. So these are the values. So we are writing value xk, bk minus fn minus k divided by fn minus k plus 1, bk minus ak. And yk value is ak plus fn minus k divided by fn minus k plus 1, bk minus ak. Okay, I think when you are at n minus 2, when k is equal to n minus 2, so that means we are at n minus k one iteration, which is last. So we are doing total n minus 1 iterations, and we are at n minus k. Then in that case, x n minus 2 becomes bn minus 2, whatever is that, minus f2 divided by f, no, it should be 3. F1, F2 we are writing as, okay.
F plus 1.
Yes, F3 only.
F0 we are not writing. So earlier, so there is a problem in Fibonacci sequence, the way we have defined. So I have to take Fn minus 3, the way we are doing. So here we are doing, so in this case, you'll get F3 by F2, Bn minus 3, An minus 3. And yn minus 3 will turn out to be an minus 3, f3 by f2, bn minus 3, an minus
F3 by F4?
F4.
F3 by F4, no?
f3 by f4. Oh,
N
okay.
plus 1, n minus k plus 1.
Okay. So here what I want f2 by
F2 by F3 if you take n minus 2.
Okay,
K equal to n minus 2.
Sorry. So now are we fine now? What we are getting, please tell me. At n minus 2, ideally it should be, but I think I messed up with some notations. Okay, fine, no problem. But we'll reach what I wanted to show.
F2 by F3, I think.
F2 by F3. Yeah, I'm sorry. Is this fine? Now, if you remember, F2 was 1 and F3 is 2. Right?
Yes.
So just to avoid the confusion, now I will be writing just B. So this is B minus 1 by 2, B minus A. Fine. So if you solve this, so this is
xn minus 2 equal to
xn minus 2. Okay. So this is B minus A by 2 and y n minus 2 is A minus 1 by 2. No, this is plus, right? Plus B minus A, and this also becomes equal to B minus A by 2. Is it okay?
Yes.
Fine.
Yeah.
So this is what happening at because if you are starting with n, we are doing total n minus 1 iterations, and at n minus second iteration, this will happen that your xn2 will become equal to yn2. Now, depending on what is greater, one of them will be equal to. So suppose we are in this situation that this is equal to xn minus 3 also. So I show you this in here because we have not completed by hand. So here if you see at this value, so these two numbers are same, x and y at 13th iteration are same, and they are same as x in 12th iteration also. So that means these three numbers, so this value we know from the previous iteration. So we are not doing any evaluation here. Is it fine? You got my point?
This last line, can you repeat again?
So I'm saying, so at this, I have shown you here that theoretically what is happening that this will become equal to B minus A by 2. Both of them will turn out to be same at n minus 2th iteration. Okay. And one of them will be equal to the value from the previous iteration, depending on how, what is the value of function. Okay. So that means at this stage, you are not performing any evaluation because all these three values are same.
Correct.
Correct.
Right. So these two values are same. They are same as here. Okay. Maybe I was doing. This is both.
B plus A.
Plus A by 2.
Yeah. Thank you. Okay. Fine. So it's already 6. I'm in little bit of hurry, but I want to complete this point over here before I leave. So in this, at this iteration, what we do, we choose small epsilon. Epsilon is some small number suitably. So I'll tell you that what is the meaning of suitably and we perform next evaluation at some number near this number. In this iteration also we are doing one evaluation. That evaluation will be done by some point chosen by us only. Okay. And after that we do comparison the way we are doing. Okay. So here what we are doing. So how, let me tell you that how to choose this number. So here if you see, so this number depends on interval size. So here if you see the interval size is very small. So this is minus 1.0, this is 0.99. So this interval size is very small. It's of 0.01 order. So this epsilon must lie in this interval. So I means must be like 1/10 of this interval. So I choose this epsilon to be 0.01. Then I choose any point. So here this value of y. So for next iteration, instead of keeping it same, I'm just changing this with 0.01. I think this should work. So now I have a different value for evaluation, but here the value, value is bigger than this also. So now I perform the next iteration. So in next iteration, to get one evaluation, I'm just using 1 epsilon, and we are performing the next iteration. Now the interval size is still refined. So earlier it was minus 1.01, now it is minus 1.00. So it seemed like if you see the values over here, the minimum value seems like -1, and this point is around -1 as well. Is it okay? So is this point clear to you? It is written in my notes also. So let's read from there. So this thing I'm pointing out, actually not n-1th iteration. So this will actually happen at n-2nd iteration. At n-2nd iteration, this will happen. So no evaluation is possible in this case. So in this case, we choose epsilon such that this point lies within interval of search. So you can choose this epsilon anything by your voicing. You should not. Okay. I'm still in the meeting, or I left the meeting?
Yeah, they.
You're in the meeting,
ma'am. Okay, maybe my screen got changed. So can you see what I'm doing? So you have to choose this epsilon in such a way that this lies in interval of search, and then you perform the next iteration at this point, and then you follow the same procedure. Is it fine?
Yes, ma'am. Yes, ma'am.
Okay, so this is, I stop here. If you have any questions, I can take that.
So ma'am, if the function value becomes same, I mean, for some value, the function values for both the variables becomes equal, then how to proceed further?
So that's what I'm explaining, that here these two values.
Not in the n-2 iteration, ma'am. If because of the nature of
it will not happen before that.
Okay.
Okay, so it will happen only at n-1th iteration itself. It will not happen. This is how sorry, this is some other. So this is what is it? Yeah, it's correct. Okay, so it will not happen before that. So here this is happening because this number becoming equal to 1/2, and after that when you are subtracting, so it is becoming, both are becoming equal to a plus b/2, a plus b/2. Since this number is not equal to 1/2 anytime before it, so it will not happen before this. Okay.
If in golden section rule, then what?
In golden section rule, this will not happen because you are taking 0.618.
Actually, it was happening in assignment 2 of question number 1.
Yes. In the first question of the assignment.
Maybe you are very close. That's why you are happening. Maybe if you take more number of decimal points, then you can see the difference. But exactly theoretically, it won't happen in golden section method, as far as I know.
Why are we choosing the small value epsilon if the same points are the same?
So that we perform one more iteration. So if you are happy with the accuracy at that point, then you can stop. Otherwise, to perform the last iteration to reduce the accuracy to get the more accuracy, we are doing the last iteration by taking certain value. Okay.
Well, it's kind of like a small manual adjustment you're doing. That's it.
Sorry?
It's like a small adjustment, you're tweaking the values to get the
yes,
value.
we are tweaking some value. So it is happening that you are something like this. So we are here is a minus n-2, here is b n-2. Then here somewhere we are getting xn+2. We are tweaking the value. So then we are evaluating function. If our function is decreasing in this direction, then we will reject this portion. If your function is increasing in this direction, then you will reject this portion. So you will get, so earlier this interval of this length, you will get interval of approximately half the length by doing this. Okay.
Iteration came as 8, right? Then we're supposed to do till like.
I'm not able to hear you, whoever is speaking. Its voice is...
Mahantesh, your microphone is not good. We are not able to hear you.
In the practice,
The Excel
Maybe we are so far.
the Excel you showed 400, right? How it comes 400? Can you show?
Himanshu, I'll try this question and then let you know what is happening here. Okay.
Okay, ma'am. Okay.
Ma'am, here we are adding epsilon, right? So we are adding epsilon to xn minus 2 or yn minus 2.
Both are same.
Okay.
Here minus, not
Yeah,
plus.
can you hear me? I
Yeah,
have
I
one question. The iteration came as 8, right? So we're supposed to n minus 2 means like it should be 6 or something, right? Like we are still going 14. Or some confusion in that Excel.
No. You are confusing two things. So iterations were coming 8 when we are doing by hand, where we were taking accuracy is equal to 1. Okay, here. But when we were doing in Excel, we took accuracy is equal to 0.02, and here iterations 610 is the value we were starting here, and iterations are coming to be 40.
Okay, this 0.02 is that accuracy and 400 is
Yeah.
that.
So more accuracy you want, more iterations you need to do. So by hand, I just was expecting 1 accuracy. We didn't reach till there also. I should have kept it 2 or something like that so that we could have completed it by hand there too. But here we can take even 0.02 also, 4,000 something. It is easier to do in here as well. Okay.
Ma'am, what is the final answer for this then? Actually, like minimum value.
Okay, so that we have not computed. So from here, can you read that answer, or you can't read that answer?
-1.
Yeah, that's the answer. So if you wish, so this is the interval we are getting, which is very small interval around -1. So I think the answer should be the -1.
So we need to complete all iterations and then we need to take minimum of a comma b.
Yes.
Ma'am,
So
do we have to take
we
average
are
of the
saying that
last?
minima lies, we are in the end, we are saying minima is lying in this interval and value is approximately equal to this value. Okay.
One question,
Wish,
guys, please raise your hand. You know, a lot of people are waiting in the queue.
Ma'am, one question, hello, am I audible?
Yes, you are.
Okay, ma'am. So we have taken the value of uncertainty like 0.02. So why we have taken 0.02? Like we can take another value also.
It's up to. It's not up
So
to you.
what is the criteria like?
We'll give you that this accuracy we want.
Ma'am, is there any assignment need to be complete today? Have you given any assignment?
You don't need to submit anything, but I have posted practice problem sheet. So it has questions on golden section as well as Fibonacci search methods. So I highly encourage you to solve all those questions so that you can perform well in your quiz one.
Is it okay we submit that next week? It's like not today.
No, you don't need to submit.
Don't need to submit anything.
It's just for the self practice.
It's for practice.
It's just for practice.
Yeah, practice only.
Yeah.
And thank you, ma'am. This is a really good session.
Okay, welcome.
Ma'am, one more question. I mean, you start with 400, right? How 400 comes? Can you?
So 400 comes from here. So when we are deciding this accuracy, we are dividing length of interval. So here interval length is 5 minus 3 minus 3, 8. 8 is interval length with accuracy. So when I'm dividing length of interval 8 with desired accuracy 0.08, I'm getting this 400. That means the Fn I should choose, that should be greater than 400. So this Fn is 3.777. So the next 610. So I should choose this Fn. Okay.
Okay.
So
So, ma'am, are you sharing this sheet also?
Yeah, I will be sharing all whatever I have written in today's class along with these two sheets on golden section method as well as on Fibonacci. Okay.
Ma'am, can
Ma'am,
we give
test
solutions to the assignment, practice
um,
assignment, so that we can know whether we are doing it correctly or not?
Himanshu, what are you asking? I'm not.
Ma'am,
Could
can
not
we
hear.
have the answers to the practice problems so that
Yeah, that can be done. So we can post solutions, but please don't see solution. It should not happen that you directly see the solution. If you first try those questions, then you solve them. Again, I'm saying that those solutions are prepared by TAs and I have not proofread it. So if you find that something is wrong over there, then you can approach me or TA or any of the TAs. So TAs for this portion is Pushpendra Singh and Barsha. Both are added in Google Classroom and you can contact them.
So, ma'am, TAs mean like who are doing the PhD here, right?
Yes, they are
Okay.
doing PhD.
Those are the calling a TA. Okay.
Okay, yeah. So they will be helping me in evaluation process.
Yeah. So today the two class was happened like machine learning AI, where the TA came to the end showing the some problem statement and execution of the program.
Yes.
So for quiz, do we need to have a scientific calculator or something?
It's up to you. Just don't solve the question using AI.
Ma'am, one question.
Can you be mute these other guys?
Kanishk, I think Kanishk.
Okay.
Kanishk, go on mute, please.
Yourself.
Good evening, ma'am. Ma'am, the topic for the test will be up to now.
Up to
whatever we
today.
have.
Yeah.
Okay, ma'am. Thank you, ma'am.
Okay.
Ma'am,
Ma'am,
one
just a
question.
question from my side, Vivek here. This optimization for data science, the thing that we are learning over here, how do we actually implement when we develop AI systems? Can you just give some insights on that?
I have
Yeah,
answered this
since
question.
he answered a lot of time. Yeah, I'm saying.
Yeah, this has been asked
Maybe
more three
I have
times and
missed
I
the
have answered
initial
it.
class.
Out of
No.
the topic, out of the syllabus.
Okay.
Ma'am, I have one question with related to basis. Actually, basis we have solved with other method, but I was just reading whether it is correct or not. I'm not sure. Even determinant, if we take, and if it is what to say, not null, then also it is linearly independent, and we can call that as a basis. Is that right or?
So here is one catch. If your determinant is non-zero, then vectors
Non-zero.
are linearly independent. So if
Linear.
number of vectors is equal to dimension, then it is a basis.
Okay. Means
Okay.
like if R3 I'm taking, so
And
there
then you
should
have
be
3 cross
three
3
vectors.
matrix. If you have 3 cross 3 matrix, then yeah, because you can't calculate determinant for 3 cross 2 matrix. So it's okay. Yeah, that method is also fine.
Okay. Thank you.
Ma'am, one question here.
I'll take a couple of questions. After that, I would like to end this call. I'm busy since morning. I had conducted one national level examination in the morning. It was a long day. Okay.
Professor, can I go next?
Should I ask?
Ma'am, when will you be giving the assignment?
I will give you assignment in the last week. Before the starting of the last week, I will be posting assignment. I give you another 15 days to submit. Okay?
Okay, ma'am. Thank you.
Okay. One more question.
Ma'am,
Ma'am,
I have one
please
question.
post the rules of test also in the classroom.
Rules of test. Okay, I will post that.
Yeah, thank you very much.
Okay, then I'm going
Is there
to.
any email ID? If you have anything to say, email ID we can get?
Yeah, I get so many emails from your class. No, you don't
Professor,
have my email ID?
No, ma'am.
Professor,
Okay.
I have sent you an email already. I wanted to ask about the date that you changed from 26 to 2nd. Just in case if I personally can't make that date, what could be the
See,
alternative?
this question also has been answered that both will be taking 2 quizzes. This is I have typed email ID in chat box. We are taking 2 quizzes and we are not taking any extra quiz for any student. We'll take best one. So both the quizzes will be for 15 marks. So please make sure that you attend at least one of them. Otherwise, because it's
What
not
would
possible to cater a request from 200 students on
That's
individual basis.
definitely the case, Professor. I understand that. Just what will be the gap between these two?
So dates of both the quizzes has been announced. First,
Okay.
I think the next 2 Sundays we are having the 2nd Feb, then 9th Feb. Both days there is a quiz.
So it's in the same week, right? Because that was the issue when it was already pre-scheduled months ago. But anyway, I will try to make some adjustment for it. Regarding the assignments, Professor, what will be the format in future when we have to submit? Right now, you have given for practice, but in future, when we have to submit, do we need to put it in a Word file, docs, or is there a
It
platform?
is the same thing. You write on a plain paper. Don't need
Mhm.
to type it. Solve those questions on plain paper. Scan it with good device or app so that it is readable. Please make sure that assignment is readable, and then there will be option to upload it. So you can upload it
Same we need to
in
do in
Google
the quiz as
Classroom.
well.
In the same will happen. So in the
Yeah.
quiz will be taken using Google form.
Mhm.
So there will be option to upload your answer there, and there will be some objective questions which you can just tick over there in
Correct.
Google form
The mix
itself.
of that, yeah.
Yeah, and for assignment there will be option to upload in Google Classroom. Okay, so why we are not giving assignment now? Because there are still students in your batch who did not get IIT JID and they are not able to join Google Classroom. So I want to keep all of them together. So that's why I will be delaying. I'm delaying assignment for a couple of weeks. But I can't delay quiz further because I don't want to take quiz on 2 days back to back 2 days. So I'm
When
just keeping
quizzes will be through Google Classroom or it will be in an LMS?
Not, I will be doing everything using Google Classroom, but I will be sharing a Google Form link. So even if you don't have IITJ ID, you will be able to access that Google Form.
Okay.
Okay.
Sure.
Ma'am, will there be any minimum passing marks criteria?
That is, so basically, if you are asking for quiz particularly, then the answer is no. So there will be so this is 2 fractal course. I'm teaching just first half of it, the first fractal. The second half will be taught by Professor Puneet Sharma. So we will be doing grading together. So 50% weightage is for fractal 1, 50% is weightage for fractal 2. And out of everything, assignment, quizzes, then there will be a major examination taken by institute. Out of all these things, worth is 100. And then passing marks is average by 2. So it's, I can't tell you the number right now. So whatever is your class average divided by 2 is the passing marks for this.
And the quiz timing is around 45 minutes, which you already shared with us.
Not 45 minutes, it will
30.
be around 30 minutes. It will be very, see, in case of online classes, we don't want to give you extra time because we have seen
No, no,
that.
no. Sorry for interrupting, ma'am. I think 30 minutes for the, to solve the question,
No,
and
no,
next
no, no,
15
no.
minutes is
Nothing like that. 20 minutes to solve the questions, 5 minutes to upload. That's it.
upload that.
Not
Okay,
much.
okay. Correct, correct.
Ma'am,
Okay.
ma'am, one query. I'm not able to trace the assignments there in the assignment section, ma'am. Where
Assignments are posted in this discussion class. It's there.
discussion
Your,
forum? Discussion forum, is it?
yeah,
Okay.
it's there. The quiz will be mix of MCQs and this detailed questions. Okay, I'm going to end this session here. I'm sorry, others
Sure.
for who are raising hand. If there is something important, you can write an email or we can discuss in next class. Okay. So there is no class tomorrow.